Welcome students to MJC Learning. This is 7th lecture of current electricity. In previous lecture, we saw what is Wheatstone meter bridge, what was balancing condition, and when there are two same potential points, there will be no current flowing through them, and the galvanometer will show zero deflection. In this lecture, we are going to study about potentiometer. Potentiometer is a device which measures potential difference with more accuracy. So what's wrong with the voltmeter? Voltmeter also does the same job, right? Voltmeter is a device which is used to measure potential difference, but not with the same accuracy as potentiometer provides. So what's wrong with the voltmeter? So voltmeter draw the current from the circuit itself. If you want to measure it with higher accuracy, your voltmeter should have very high resistance. And what about potentiometer? Potentiometer doesn't draw current from the circuit. So potentiometer here provide more accuracy than voltmeter. So our topic name is potentiometer. So what does potentiometer actually looks like? Actually, just like Wheatstone meter bridge, it has a wooden board on which a very long wire is mounted. So its length is L, consists of a long wire AB of length L and resistance R, and having uniform cross-sectional area A. E is a cell of EMF E and internal resistance small r. You can see everything in here. When the circuit is switched on, the current I passes through the wire. So before we start with this current and voltage thing, I want to tell you this potentiometer works on a potential gradient principle. Now what is this potential gradient? You already know what is gradient. Gradient means slope. So let us go directly to the potential gradient first. So now same wire A and B. Let us consider A is a point at which potential is A, VA, and B is a point at which potential is VB. VA is greater than VB. So definitely there is a potential difference. VA is greater than VB. At L is equal to 0, it is VA, and L is equal to L, VB. So if every red dot is considered as a point on the wire, and if we measure potential difference across it or potential about it, it will decrease. That is one of the reasons, that is from higher potential to lower potential, there is a constant decrease in the slope, constant decrease in the potential. So the graph would look like this. Now I want to find out what is the potential difference per unit length of your wire. That means in every unit length of your wire, what will be the potential difference? That is, what will be VA minus VX. Now this is the point. So it is simple as divide the potential about this point VA and VB, that is VAB, divided by the whole length of your wire. Now this quantity is also called as potential gradient. Again, what is potential gradient? It is potential difference per unit length. I hope this is clear. What is potential difference? Potential gradient. Potential gradient is potential difference per unit length of your wire. In every unit length of your wire, what is potential difference? That is called potential gradient. Actually, it's not exactly like this, but it wants to say that how potential is decreasing through your wire, and it is constant. Let us see how it is constant. I hope this point is clear, that what we are going to find. We are going to find from our previous circuit VAB by L, that is potential gradient. Now let us see how we are getting it. So where were we? Here. When the circuit is switched on, current I passes through the wire. Current through AB is given by E minus IR minus IR. This is from Kirchhoff voltage law. This equation is from Kirchhoff voltage law. And So I will be equal to E by R plus R. Again, what is the aim of our this derivation? We have to find VAB by L. So I know the current flowing through this wire. So now I want to find potential difference at point VAB. So I know resistance of your wire is R. Resistance of your wire, this wire is R. And I want to find potential difference VAB. So it will be nothing but I into R. So going back to our new slide, potential difference across AB is V. AB is equal to IR. Again, I have shown you what is R, resistance of your wire, and I is current flowing through the wire or circuit. So I already find out the current flowing through the wire is E by R plus R. This is the answer. VAB is equal to E by R plus R into R. Next is potential difference per unit length. As I previously told you that we are going to find VAB by L, that is nothing but potential gradient. So it is nothing but E R upon L into R plus R. Now, tell me guys, everything here is constant. Resistance of your wire, internal resistance of your battery, and L is the length of your wire. Only problem is E. Until E remains same, your potential gradient will be same. I hope this is clear. So at every point potential gradient will be same, or the decreasing will be same. Again, potential gradient can be defined as potential difference per unit length of your wire. Here SI unit I have written volt per meter. It is also represented by a letter K, V by L. I hope this all part is clear. Potential gradient is nothing but potential at a unit length of a unit length. Potential difference of a unit length, not potential. Guys, potential is difference and potential difference is different. Okay, so here we found out what was potential difference per unit length. So now if I want to find out for a certain length L, if I want to find potential difference for a certain length VA to C, so what I'm going to do is I'm just going to multiply potential difference per unit length into the length of your wire, whose potential difference I'm going to measure. If I want to calculate potential difference for small length L, this small length L, I'm just going to multiply it with. So VAC will be nothing but VABL by L. I hope this is clear. It is just as telling you that I know the cost price of one pencil is 5 rupees. So what will the cost price of 6 pencil? So you multiply 5 by 6. Now how we will be measuring potential difference of this EMF E1? So what we do is I connect the positive terminal of your battery EMF E1 with our internal battery. Positive terminals are same and negative terminal is connected to galvanometer, and another terminal of galvanometer is connected to jockey, and this jockey is tapped on wire AB at different points. And now we know already that if potential at 2 points is same, then there will be no current flow. If E1 suppose at point L, if galvanometer shows zero deflection, that means that potential difference about point AC will be same as E1. So here comparison is directly done. So this method is using comparison method, not any current is drawn from this E1. There is no current is drawn from this E1 because at C point, at this point, galvanometer will show zero deflection. That means the complete potential difference which is provided by this EMF E1 will be directly given by this letter L, small l. Now what is this L? L can be measured with the help of meter scale. So if I want to find potential difference at point A and C, potential difference at point A and C, so what we are going to do? Simple, this. Sorry. here. Simple. This apply this one. Potential difference at point A and C, VAC is equal to potential difference per unit length, that is K into L. So what will be the answer? VAB by L into small letter L. I have written it here. Look, this equation. So I will directly get the answer of E. So what you concluded here is E1 is proportional to L. Okay, so are you able to understand that now VAC will be equal to E? What is VAC? Potential difference at VAC. And why we are considering only VAC? Because at point C, galvanometer shows zero deflection. And we always knows that when galvanometer shows zero deflection or null deflection, current is not flowing from your battery. And it also shows that the potential difference is potential at both the ends is same. I hope this point is clear. In my next lecture we will be studying combination of EMFs and we will be calculating EMF of cells E1 and E2 by combination sum and difference method, and internal resistance of your battery will be also calculated with the help of potentiometer. Okay, thank you.